pop. That's my synchronize the sounds. Wait, am I recording?
Yeah, you're good. I'm just mic checking
right now. Mic check, mic check. We'll find out.
It's gonna be a shit show, bro.
I recommend everybody try out Miro whenever you're making a large project. That way you can just put your mind into a giant map of arrows and titles. It's all pretty straightforward when you break down a large task into a bunch of small tasks. It just really comes down to doing it. So here you can see me animating all of my guns forever and always. Have fun with it. This is the part I actually enjoy the most, is playing around with the graph editor and all the different poses you can make your things do. So at some point you're gonna fuck around long enough to have gotten a result that you liked, and once you got that, you're gonna want to export as an FBX. I have the armature and then the mesh together. Keep it down out there. And I export it to Unity as an FBX and then rename all the files. Personally, I like coding for a generic rig, or not a generic rig, a legacy rig. So I have that swapped to legacy. Now here in the script, you're gonna want to make a direct reference to your animation component. This is gonna control all of the animations that play on your game object. And because the animation component is on the game object we're putting the script to, you could literally just assign it as a get component and then have your component got. I don't know what the fuck. What do you want from me? Oh yeah, it's a gun, so you're gonna want to put a fire rate variable. Along with this one, you're gonna need an unnamed, never visible, never really used variable called nextFire. And I don't know exactly what it does, but I know it works. So right now we're grabbing the firing animation, because every time the player clicks the button, we want to see the animation play. So we make a reference to the animation clip. And for checking to see whether or not the player has pressed the button, we're going to do an input.getButton, not getButton down. GetButton down is for only one press, while getButton is while the button is being pressed. We're also going to check to see if nextFire is greater than time.delta-time, or no, sorry, time.time. Again, I don't know exactly what any of this means, I just know it works. You're going to add the fire rate to time.time, and that's what your nextFire is going to equal. And now that we're checking for every time the gun is fired, we can have the effects pass called. We're going to create a new void called effects. We're going to call that effects every time the fire button is held down, and then nextFire is greater than time.time. And as you can see, you got the animation object. It's going to play the animation. Never call it by name, so that way I don't have to type out the name of the actual animation clip. Once we pull the code in, you're going to drag your firing animation to the code and give it a good old test. I had forgotten a small detail. Before your firing animation plays, you're going to want to make sure that you have the animations all stopped altogether. That way, whatever animation is playing, it stops to play the firing animation. But that's pretty boring. I have 3 firing animations and we're only playing 1. So you're going to turn it into an array by putting these square brackets at the end of the animation clip variable. And now what you can do is play the animation by name, and then inside the square brackets you're going to put random.range, and the first number is going to be 0, last number being the firing animation length. Now every time this animation is called, it's going to play one of the 3 animations randomly. On the left side, you can see what it looks like to play the same animation over and over again. On the right side, you're going to see what it looks like when 3 different animations are being played randomly, and it's pretty obvious which one's better. At this point, we're going to start doing the recoil. So I get a direct reference to my my player look script, which is basically where the mouse is controlled, or the camera angle is controlled by the mouse. And instead of doing a get component, I do a get component in parent, because the parent is the one that has the mouse look script, not the weapon object itself. And now every time the effects pass is called, I'm just writing a line directly to that script called X recoil and Y recoil. So I'm gonna pass a fuck, dude, this is ass. I don't know what I'm doing. I'm fucking up hard. Get it together, man. We're in showbiz, dog. Yeah, and so now with the look object. Yeah, you need to shut the fuck up, bro. So we send a message to the look script with the X recoil, and then use weapon recoil.x in that vector 2 we set up earlier. And then we're gonna do the same thing for the Y recoil, but how this is gonna work is instead of just the Y variable, it's gonna be a random.range weapon recoil.y and then negative weapon recoil.y for the opposing side. Plug in the variables in the inspector, and now when we play, as you can see, with no horizontal recoil, the gun goes straight up into the fucking sky. And once we plug in our horizontal recoil, we now have a challenging game. Oh man, how poorly have I been talking into this mic? Oh, it's much better. So yeah, the aiming script is pretty straightforward. We're going to set up a basic boolean as to whether or not the player can aim or not. We're going to set it to true by default. You need a vector 3 for the hit position to the aim position. And you're always going to be affecting the transform.local position, because if you do it in global, it's going to look really weird. And then you need an aim speed for the float, or you need a float that is the aim speed, pardon my French. If the player is pressing fire 2, which is the right mouse button by default, then you can have it set for the local position to be the aim position. Using an else statement, you can have it set to be the hit position. You're going to multiply the aim speed by time.delta time to make it a smooth action. All of this is going to be through the power of vector3.lerp and all the mathematical stuff that does, and I don't know how to explain. I don't know, find like a nice little iron sight position, copy those numbers from your transform into the hip and aim position of your aiming script, and now when you're playing your game, you should be able to aim just fine. It looks pretty cool. Looks like a video game. I'm lazy. I go to the internet, I download the PUBG AK sound effect because it sounds meaty, sounds kind of badass. Back in Unity, you're going to add an audio source to your game object or your gun object. And then inside the firing script, we're going to add an audio clip as well as an audio source. Now for the audio source, you can get component, make a direct reference to it on start. Now inside your effects call, you can do audio object dot play one shot, and you don't need a dot name to call something by name, but firing audio as the audio you're playing, and bada bing bada boom, you now have gun firing audio in your game. Oh, so here's more artsy, creative, fun shit. So I want to make the muzzle flash, and I bring it here into Photoshop, and I use an inner glow and an outer glow to create a muzzle flash. Just use the lasso tool to make a generic shape. It doesn't have to be too great. I wasn't a big fan of this generic shape, so I end up redoing it so it looks more generic later. You're going to save it as a PNG file in your Unity project, and then you're going to start playing around with the particle system to make your muzzle flash. Give it some random rotation, random scale. Should be perfect. Once you get into the coding of it and you have it aligned with the barrel of your gun, all you're going to want to do is inside your effects path, will make a variable about the particle system that is the muzzle flash, and then inside of your effects path, what you can do is just muzzle flash.emit, and all you have to do is put in a 1 inside that little bit, and bada bing bada boom, we have a muzzle flash on the end of our gun. In the same place you put the particle system, you're also going to want to put a point light inside your script. Make a reference to that light. You're gonna have to place this one manually in your inspector, and then in the update function, make sure that the intensity of your light is always coming back to 0. Oh man, I use alert function because if it's instantly and people have too high of a frame rate, the light's only visible for 1 frame, and that doesn't look good. So mathf.lerp, whatever the intensity already is, to 0. I'm just putting 50f for the speed times time.delta time. That way, no matter what intensity it is, it's always going to come back to 0 regardless, gradually. And then the effects function, you're going to set the intensity to a random.range. And I think here I put 0 and 3, which I later end up changing to 6 and 10. Intensity goes a long way. Oh shit, we're doing the shells. And luckily for me, I'm autistic for the details, so I modeled my guns with bullets in them. I take one of the bullets, I export the shell to Unity, get it looking nice. I got a material on it that looks something like a bullet shell. Nothing's final. It's all a work in progress, as the developers like to say. Everything's subject to change. Inside the code, we're gonna make a game object, call it shell object. We need a transform, which is where the shell is gonna spawn from, not the bullet. The shell is gonna spawn from, and then a new vector 3, which is gonna act as the minimum shell force and then the maximum shell force. So however much force it's gonna be to be setting the shell out the side of the gun. Because, I mean, if you just use one number, it's going to do the same thing over and over again. It looks kind of boring. For variance and interest, it's nice to have like a minimum and a maximum. So here in the effects tab, we're going to make another game object called the shell instance. And then this game object is actually going to be an instantiation of the shell object itself. We're going to spawn it at the shell spawn position. And then it's also going to show the rotation of the shell spawner, and then we're going to instantiate that as a game object. And then every time we make a reference to shell instance, we're actually making a reference to the game object being spawned in. So now, fuck! It's all part of the chaos, man. It's the video now. It might be good, it might be trash, I don't know. We'll see in the editing bay. Oh yeah, so when referencing the shell instance, we're able to add a relative force, and each angle of the relative force x, y, and z is going to be a random dot range, and then a reference to the minimum shell force, the maximum shell force with their respective x, y's, and z's. Back in the inspector, once the code is compiled, we start plugging in random numbers to see what looks good and what works and doesn't work. And then once that's done, we've pretty much done it all. We have our recoil, we have the shell ejection, we have the muzzle flash, the muzzle light, we have the sound effects, we have the recoil animations. So I'd call that a good gib, and it's a code that we can reuse for multiple guns down the line. Bada bing, bada boom, fuck you, that's the video.